Created in 2005 and hosted by security industry veterans, Paul's Security Weekly is your source for in-depth coverage of the latest vulnerabilities, exploits, and security research. Our weekly security news discussion dives deep into the security issues we face today and potential solutions in a fun and lively atmosphere. Each week, we bring on guests from the security community to learn about their journey and discuss topics relevant to their work and research. You can also subscribe to our show by visiting securityweekly.com/subscribe or look for Paul's Security Weekly in your favorite podcast catcher. We've recorded a ton of content over the years, so we created Spotify playlists featuring some of our favorite episodes, including interviews with Marcus Random, John McAfee, and Chris Roberts, to name a few. You can find them at securityweekly.com/starter packs.
Welcome back to Application Security Weekly. We just talked with Emily Fox about the pieces of a vulnerability program and what it takes to fix the vulns you care about. I'm your host, Mike Shima, and I'm here with John Kinsella. And John, it's good to have you back for the news segment. We had Farshad last week actually walk through a couple of the articles with me, which was pretty fun.
Awesome. Yeah, great guy. I'm sorry I missed it, but I left you in good hands.
Yeah, in good hands. And hopefully we will see him and other listeners at RSA Conference, because guess what? You can save $100 on your RSA Conference 2024 full conference pass. RSA Conference will take place May 6th through 9th in San Francisco and on demand. To register using our discount code, visit Security Weekly. I'm not going to get through any segment without misspeaking. Visit securityweekly.com. You've heard it every week. You know what the URL is, /RSAC24, and use the code 54USECWeekly. All right, John. One of the things before we dive into news, I did mention at the opening about, a March Madness of InfoSec myths and misconceptions and mistakes. And, wanted to call out to our listeners to see what are some of their pet peeves, their favorites that they think sounds like good advice, but is kind of bad advice and even harmful advice maybe. And for me, just as a quick example, I think all the discussions like doing training and talking about phishing as smishing or vishing and all the various naming and taxonomy of how phishing attacks occur seems kind of pointless. The training is more about people may be attempting fraud on you, tricking you into things, clicking on links. So have MFA, go through the exercises of that, enable auto updates. And, to Emily mentioned, it depends is one of those famous security phrases. But I think all those things that it depends on are more about what can people do rather than care about smishing, vishing, or even QR codes now. So that's a little bit of the example that I'm going after here in terms of misconceptions or myths. So I don't know if that resonates with you or if you want to take it on a different angle.
It resonates. On that one first, so when I was first studying for my CSSP, how many years ago that was, one of the concepts that really struck me in there was, the reason that we have formal vocabularies for a lot of things in not just in security, it's a lot of sort of different areas out there in the world, is so that we're able to communicate on a common language and understand each other. I think that has shifted a little bit over time to also be, once you have a sort of a standards thing, particularly in security, that's now something that vendors can say they either prevent or they cause or they'll save you or whatever, right? They can now use that in their marketing to sort of get their message across about why they're awesome. And I think that particular category you were talking about is unfortunately partially, I think, due to that. Man, where would I go with this one? I've been thinking about it. It's like, what do I think is overblown or mythical? I think, like you, in a way, a large portion of me, I'm answering in reverse, is to do the basics and to sort of, if you get those basics in place, then I don't think you need. Emily, for reasons, is a big fan of brain blanked. The languages, which are the documents which come up and tell you all the stuff in your software, the assets. Oh my God, my brain. Anyways, it's her and a lot of CNCF are fans of this, creating an SBOM. To me, I think an SBOM is a myth.
Interesting.
I think they're nice in theory. I think I've only finally seen like one tool out there really being able to consume them and make them useful. They're easy. They're becoming easier to generate, but what do you do with them? So I think personally that's my hot take and myth is SBOMs are not so much, at least for me.
Not so much. Yes. And that's what we want to hear about. And I think the reasoning really is what is more helpful here and educational. So thank you for that. And listeners, tell us what you think of as your myths, because it's the reasoning and how we get there that I think is the interesting part that we can learn from. Just like we can learn from news of the week, things like SilverSAML. John, this is a riff off of the GoldenSAML, which was in the Microsoft AD environment so a while ago, which is basically predicated on don't leak your private keys. So to me, the article was a little bit maybe more copper than silver in terms of value of the risk rating, but it's still a nice background of SAML in general, a little bit of the differences and nuances of certificate handling. For example, I didn't appreciate that you don't really need CRLs, OSCP within the SAML world because it's not so distributed that if you were going to say this cert is bad or it's been exposed, just delete it so it can't be used to authenticate. So small things like that about good practices. But it does boil down to, I think for me, protect your private keys or, have a policy about where keys are generated and what systems they can touch so that this private key material is supposed to stay within an HSM or within a system and not go onto a laptop, let alone into a repo. So that was a little bit of the more general takeaways I found for this particular article.
Yeah, SAML is an interesting beast. It's not something you can just turn off, right? It's used by a ton of enterprises out there. Most of the time, we don't see it being used on public side. Usually, there's other schemes to do something similar. And I guess sort of the thought to me is, besides you were saying like how do you get these things configured right, or which ones do you use? Is there something that we should be looking to replace this with or go towards something else? And again, it's not an easy thing because it's not like your own application. You're just passing SAML back and forth between two apps you've written. Usually you're working with some sort of third-party identity provider. So unless you're going to go that whole big leap and jump and replace that, you're more sort of waiting for those identity providers to say, hey, we're now offering this other way of doing this. And it's unfortunate because I can see the value for a hacker and a company to go after something like this once they breach the external perimeter, or if they're inside, however they got in. If you can crack that identity provider, you've got the keys literally to the kingdom. So it's almost a bit of a, at least the way I think of it, and not just there's AppSec aspects to it, but there's also a lot of operational security, I think, too, IT security. So
there is, and
head scratcher.
And it's a good callback, I think, to our discussion with Emily in the sense of, a common way in and a favored way in for attackers is valid credentials. Whether they do get them through phishing, one of those mechanisms, or they've compromised that key, that's so much easier, often less detectable, less noisy, at least, than using whatever exploit there is. So just one of those important things to think about when you're threat modeling how attackers are targeting your org. But John, you also mentioned the idea of, there's third parties, there's an ecosystem around SAML. Getting an ecosystem, because I like saying that word, to change can take a while. I wanted to tie that in with the other article I have about Hugging Face and using Python pickling, because pickling is a nice, effective way for sharing model weights and model data, but it just so happens to have some, that classic deserialization vuln that can lead to arbitrary command execution. So these can be arbitrary objects, and pickling can do this. Java has its own, deserialization and arbitrary command execution as well. So it's a type of design consideration or language feature that's not specific to Python. And Hugging Face themselves has been working on safe tensors. And even last episode, I mentioned this briefly with a discussion with Farshad about about how some researchers at Hidden Layer were looking at compromising the conversion from a pickle into safe tensors. But I think I just wanted to highlight this in the sense of is serialization something that would be next on the chopping block after memory safety? Should we get the White House and to say serialization is just a insecure design? It's a scary design. It's leading to vulns, or is this too few and far between? I don't know. That's my thought when I was looking at this.
It sounds like such a nerdy thing to be coming out from a high government.
It does.
But at the same time, as I think about that, I'm like, and we're going to talk about this probably a little bit, but here I'm talking. I imagine this doesn't just happen for I'll say computer security. I'm sure it's happening for other areas where different parts of the government will say like, hey, this is, we need to stop using X fertilizer, or you see it with like pesticides and things like that. So now we're just getting our turn, I guess. But here, what's interesting about this, so there's this article, it's funny, I saw it in some different ways. It's different media centers sort of highlighted different parts of it. The one that really caught my attention was JFrog found actually over 100 of these malicious models on there. So and I don't know if it didn't mention that they're all from the same author. So people are playing with this idea of like, how can we get out there and sort of poison? It's interesting from a few different points of view. A just said poisoning. What can you just, if you can get someone to run it and just purely manipulate the results which they're going to then publish or whatever they do with it, that's one interesting aspect. The other one, I think, from a computer security point of view, though, Mike, I think about is, and I'm just going straight to how you'd use these. People really need to think about egress filtering once again. This is something which, some of us are huge fans of, we've done for many, many years. We've tried to push people to do for many years. But you don't see, especially with cloud, I think people always think about what's coming inbound, right? So if you're going to go rent, 50 of NVIDIA's greatest at some cloud place and do some crunchy on them with the data that you uploaded and store there. So you got some large data set, you've got some model that looks pretty good. You don't have to have people to build it yourself. If this model, arbitrary code execution sounds great, but can we actually gather some of that data that's being used and then use the code execution to push it back and egress out somewhere else? That could be quite damaging, right? And again, I think one of the biggest problems people are seeing right now with machine learning, training these things, excuse me, I forgot my rainbow hands, is how do you train and consider information privacy and personal privacy? So if you want to actually do some decent training, there's a good chance you're going to have faces or medical information or all these type of things. And you're trying to, de-risk it and do all the right things. But if someone now, you're thinking you're just running in, like, usually the thought has been it might leak into the results, which were, in the search engine if we're using it. I keep thinking about ML search engines. Don't know why, but use that example. But now if someone is able to actually upload this somewhere else, the problem becomes much bigger. So TLDR needs to be taken seriously.
It does. And I like the idea, or I like the concept that you mentioned, egress filtering, because that would go back into our conversation with Emily in the sense of what are the precursors to a vulnerability program? The quote unquote easy things to say of have an asset inventory, update who owns the asset so you can find that person, and do egress filtering. Those can all be great things that can minimize the risk of your environment.
Seriously, just for a second, think about how many attacks. I know myself have stopped just because, someone breaks into a system, but they can't get their connection controlled or to go back out, command control to connect back out, or they can't export data, or they can't do whatever they're doing. It's so powerful and so underused, but.
Ooh, and it also knocks against one of my, InfoSec myths. Attackers only need to be right once. Defenders need to be right all the time. I don't really buy into that because, as you were saying, especially with something like an egress filtering, or even just within cloud and monitoring, attackers need to be careful all the time, and defenders need to be right once. I'm inverting it a little bit facetiously, right once for that particular event that triggers. Now, maybe it's not always in once, of course, but realistically, if you have that observability, there are flares that go up that show activity that looks hinky, that shouldn't be there. We do have a bunch of other articles to go through. You grabbed one. Speaking of things that I think even So DNSSEC. It has sec in the name, but a lot of the AppSec, InfoSec folks I talk to are really skeptical, to say the least, about DNSSEC. And here is a vulnerability within it. So this sounds like you're going to have some fun, John. Tell us about this one.
Yeah, I've had a very long running battle with a very good friend about DNSSEC, and he bought into it like hook, line, and sinker from day one, and he loves it to death. And like, I've never touched the thing. I'm like, that's too complicated. There's just no way that's going to be perfect. And I'm not trying to say I told you so, Bill, but yeah. So what we got here, this is a vulnerability which, so we're talking about this thing called key trap, because we have to get back to our branded vulns. And some folks, I believe in Germany, yes, found this. I believe they're doing a manual code review. So this is actually a flaw in the design of DNSSEC. And let's see if I can get all the points right. So the link which I have in here is to the overall sort of the web page for this thing. For those who are interested, there's some sections on like a FAQ, I'd call it, and an accordion down at the bottom. Right above that, there is a free, no login, no anything needed, no email PDF that you can download and actually dig into the meaty on this guy. But in a nutshell, the way DNSSEC was created, or how the way the specification is done, is you can have collisions in the keys which are used to sign and to verify your DNS record. So DNSSEC, the idea is if you're able to sign the records, then someone can't spoof your stuff and do all the standard type attacks which result from spoofing, man in the middle, et cetera, et cetera. So first is you're allowed to have key collisions. And what that means is the algorithm is written, which they show in here, is a for loop. So you have to, the DNS resolver has to collect all the keys for that record or for that domain, and then literally loop through until it finds one that works. The second thing is you can have multiple signatures, because if you have multiple keys, you might have the one record signed by different keys. So then you have multiple SIGs. So another for loop, right? And what this ends up being is you're able to have a malicious key or malicious signature in there that when it goes to decrypt that or try to validate the signature comparison, you end up in a DOS situation. And the number they've got in here, if I remember right, it increases CPU usage by 2 million times. So if you can have one DNS result suddenly take 2 million times longer than like a fraction of a second, and now if we can even think about having 10 or 15 or 20, not alone thousands or millions of those requests come in, that would give you what you call a bad day. So they refer to this as one of the worst DNS vulnerabilities. Yeah, the worst vulnerability ever found in DNS. I don't know about that. It's the authors sort of patting their own back. Hey, it's pretty cool, but still this would have been a huge deal. They worked with a lot of the major DNS vendors and services out there before this was published to get these things locked down. So it's not really an issue anymore unless you're be one of those nerds that's running DNS at home and you haven't updated your servers, and you might suddenly realize that there's a problem. But bring it back to AppSec, and it really sort of gives you a sense of as you make security things more complicated, to bring in the support for multiple keys or multiple signatures, or you're like what ifs. It's basically if you do too much of this what ifs when you're doing your design and you don't sort of keep what's simple and clean and efficient, the design can be more complex and that could cause problems, but then also the implementation of that design, which is the problem here. I don't think the design was complex here, but the core issue at the end of the day is the implementation of that design didn't have enough controls around it, right? So, yeah, that's something to think about and try to not replicate.
Not replicate, yes. And I love this because it's protocol analysis, and that combinatorial explosion has nothing to do with memory safety. So it's one of those things that, yes, let's continue with memory safety, but memory safety is just one class of problems. And we're going to be busy. As Emily said, AppSec is going to explode, and you can interpret that in a couple different ways, to be honest. But it also means it's going to have job security because, yeah, exactly. So let's see, what else should we take us? Speaking of job security and things that can explode, and maybe there are IoT devices. And John, I think you've played with some IoT devices. I don't know if you've ever done the physical playing with them, where you just touch a pin and some of the magic smoke escapes from the CPU, and suddenly that IoT device doesn't work anymore. But so you probably need a testing guide that at least walks you through some of the categories of testing and what those components should be, in the sense of, here's the memory of the firmware, this aspect. So we have from OWASP the IoT Security Testing Guide. Seems pretty good. First, as listeners may know, I'm like, wait, what? Another thing? That's a cookie cutter? Like, this is another top 10 list? It's not quite that. This feels like a testing guide in this domain space is useful for language, as you were mentioning earlier, as well as there's differences here. What level of physical access do you have to a device? And that's quite different in concept of what you can test for, or what the security concern should be, or threat models, probably the word I should be looking for here, than you go through necessarily on a web application, for example. So it's the 1.0 version. It's just out there. So it's now made contact with the enemy, so to speak, as all the researchers in the world start taking a look at it. But if you have, it's there for feedback. And they're also working on a security verification standard for IoT. So this is a little bit, we just last week talked with Farshad about pipeline security verification standards. So some SVSs are starting to be, this is not the year of top 10s, it's the year of SVSs perhaps. But that was a little bit my impression. I don't know how much you had a chance to look at this.
I'm going to try to, I haven't read through all this yet. I want to try and dig into it a little bit deeper and see how it compares to some of the hardware testing, IoT pen testing books, which came out last year or two, because those were quite good. As usual, at the top of the testing guide, they've got a pretty picture, so I focused on that. And I think that, so they've got this, it looks like an org chart, but it's sort of a flow of how do you go about testing these things. And it sort of goes through like, okay, processing unit, memory, firmware, data exchange service, internal infrastructure, physical interface, wireless user interface. So it sort of gives you a starting point of pick one of these things, go down through it. The magic smoke is definitely a thing. Lovely smell. The interesting part about this when you're doing physical testing is usually I keep looking around, there's usually one on this desk somewhere, but the cheap ones are like, okay, if you blow it up, you buy like 10 of them for, $5 from Amazon, not a big deal. As you go and start doing stuff where things are interesting, if you can find that device, the idea usually is if you want to go and do a pen test somewhere, you go and look and see if you can like pick one up used off eBay or something like that, right? And then like do your practice testing before you go and attack. Even the used prices on those things can be quite high. So if you touch the wrong pin, or you don't know what you're doing, or you haven't practiced, or don't know what's going on, the chance of failure is high, and the results are very quick. So, it's something you have to be sort of careful and read and study. It's one of the more, I guess I was going to say it's one of the more interesting parts of security because you have to be a little more practiced before you get into it, but it is probably similar to anything else, right? We talk about from the point of view of how do you get started in security or testing or things like that. So I guess the analog of me saying, go to an open source project and get, as Emily was saying, get involved in CNCF or those type of things, would be to start with that cheap chip and like understand how to test that and what the different pins are and how that goes. And then from that, you sort of slowly work your way up to the ASICs of the world and things like that.
Yeah. And probably, DEF CON has their villages and IoT villages, and they have a lot of equipment to help you just understand what does it take to build your own home lab. So you can also, so I'm just going to pitch that as one of the villages. Before you invest yourself, you can just go and play with toys. And it is very physical. So there is a fun part of that. But for me, I will always appreciate that it's much easier to debug and analyze things with printdef than it is with a voltmeter. So that's where my brain works. So that's why I went to the web hacking world of JavaScript rather than firmware analysis. But speaking of maybe complexity, there was, I think we talked a little bit about the State of Rust survey a couple episodes ago. I'm trying to find my notes from that, but you pulled out another article on this and a different, a particular angle you wanted to address here.
Yeah, we've got a few Rust stories today in our show notes. We'll see how many we get through, but I feel like there might have been one of these a few months ago, but this is really came out in the last week or two, and it is partially from the State of Rust survey. But in particular, what caught my attention here again was people are concerned about the complexity of Rust and what that results in. Like, do people actually want to dive in and like learn this language? It's a little more complex than others. Or do they want to stick to something they know, or maybe go to JavaScript, which has a lower learning curve, or how they want to deal with it. The other aspect, which I know the Rust community is working on, I'm not sure if it's covered in this one. No, it's not. And I was thinking about when we were talking to Emily, we're going to see how many references we can bring back to that first half of the show today. Is, as you think about, oh, it's part of my CI process and I just like update the code and it deploys and out it goes. What I've seen from experience is if you've got a large program written in Rust, when you go to do that CI thing, that build takes a while, because the way Rust works is it wants to recompile the whole life cycle every time. And there's ways that people are working on to sort of fix this. And we covered one last year with, I can't remember the library, but they started trying to include binaries, and that really sort of rubbed people the wrong way. But yeah, there's multiple angles to this, right? And the point I wanted to get across was it's not just like, oh, pick a memory safe language. Let's go and just, as she said, either rewrite everything in Rust, or even just the concept of picking that language has a lot of these, as you were saying before, ecosystem issues which sort of come along with it. So you're not just getting married to your significant other, you're getting the whole family.
And part of, to expand a little bit on that, like even the Linux kernel, I think, if I'm remembering correctly, it's around 5 million lines of code that compiled down into what most common Linux kernels that people run today. And Rust is being adopted, but it's explicitly not going to turn into a Rust-only kernel. They're going after, taking a risk-based approach. Let's go after the device drivers, the areas that commonly are, they're user-facing, they commonly have security problems. So that seems like a smart choice. The other thing from this survey that I thought was nice, and had my eye on, is that WebAssembly shows up 4th in the list of runtimes being developed for. So people are using Rust for WebAssembly, but I don't know what for yet. So I want to find some more examples and see how people are using that. And the other thing, just as this bugged me when I read the survey, the Rust survey, it starts with an awful pie chart, with like, I think at least a dozen different items within that pie. A table would have been better, or even if you want just some horizontal bars. Horizontal bar charts can go a long way. It makes it even legible for labels. So a little bit of lesson in communication there. I had to do that.
Yeah, it's particularly for that chart. I'm not going to talk about what the chart's about because I want people to go and find it. But I'm suspecting the authors had a point of inclusion and didn't want people to feel left out. So the next thing you know, you've got a bunch of these. What are these, like even 1%? No, they're, oh my God, they're 0.1, no less, 0.05%, 0.02, so 0.01. And I'll let people go and figure out what we're talking about. But yeah, it's focus on maybe the top 10 next time.
Yeah, maybe just that. I had included a quick, I'll mention it just because we were on the topic of Rust. Rust TLS is now supporting AWS libcrypto, and they're doing that for FIPS support specifically, or that's a benefit. And that's one of the things I'm saying out loud more as a reminder to me, is that there's also a lot of external requirements that influence the adoption of tooling or influences the direction of features. And you mentioned FedRAMP, for example, back in our previous segment. The government, U.S. government world at least, FIPS is something important to them. So we can't just rip and replace everything and assume that all of our users are going to be, happy or their needs met. So it's, I suppose, maybe a little bit of a product manager hat on if I can dare venture into such language. I don't know.
Oh man, I didn't realize there was so many here. I'm just looking at a sentence from this post. I didn't realize how many different. We're getting back again to the how do you know which way to go? So the sentence is, the community has started to add support for cryptography from Rust Crypto, Embed TLS, and Boring SSL. We hope to add support for SymCrypt soon. like SimCrypt, what's that? Oh, Microsoft has their own version too. So you've got 1, 2, 3, 4 different, 5 different SSL libraries, TLS libraries, crypt libraries on a relatively new language. So it's not like we're talking about like C or something that's been around for decades and like everyone's sort of created their own version of, something. This is, and I know Rust isn't brand new, but which one do I pick? And as you said, with the FedRAMP type things, where in particularly for me, the way I think of it for FIPS, that's a really particular, that's a pretty picky little thing to get that certification or to keep it. So which one of those? And like, you're probably not thinking about that when you first picked the library. You might be, but it's usually a year or two later when like you go to get the certification. Maybe we need to find a blog post on that. Which Rust crypto library should I use?
So, John, in the spirit of as many references as we can make back to Emily and the last segment, she did mention the White House press release and the continued push on memory safety, which overall, again, very good thing, despite pointing out things like key trap are design issues, protocol issues that are still going to be out there, even when we get to memory safety. But one of the things that I thought was kind of interesting, and I already talked about this a little bit in the last segment, is they made a big deal about referencing log4shell, which makes sense about impact. People were scrambling, et cetera, et cetera, et cetera. But log4shell was not a memory safety issue. And it also highlighted, again, what I mentioned last segment of why did we have this feature in the first place? Nobody was really using this. It was on by default. And it just became a liability for everybody that had installed Log4j, or Log4j, depending on your pronunciation. So to me, it's nice to see it included. Obviously, had that impact, but it's a very different conversation. Is where I would take that as well. So a little bit of food for thought. I thought. Not sure if that was enough for you to bite onto, or if we can perhaps move on to another one of the articles.
As I made in the last half, my joke for the last week on this has been, so we're all going to start using Fortran, because like I was just looking at the doc, and I don't see an actual list of languages in there. And the way people are, so Rust is mentioned, C++, is Fortran mentioned? No. Fortran is perfectly memory safe. So I'm going to be making this joke for the rest of the year. Sorry. The part which is interesting to me about this, and I'm seeing it in some other situations recently too, which is why it sort of caught my eye, is, and I get it, and as you were saying with the Log4j, I'm going to start using that too. A lot of the times what I'm seeing is when, I'm going to say, academics are making these sales pitches to executives or non-techies or whoever holds the purse strings. And I'm talking about this from, I want our listeners to think about if they're, if you need to get buy-in on something, we've talked about this before, how do you get the manager to like sort of, understand the severity or give you the budget to let you spend time on it, or all these type of things. But what I'm seeing in a lot of these type of things recently, why are they mentioning the Morris worm from 1988? Or Slammer worm from 2003. And I understand what they're doing. They're basically going, hey, see these things from the past that were like so horrible? Do this and you won't have that problem. But I guess it seems like when you're making that argument, use something that's a little more, relevant. But also the second part is don't use the same. If there's just one example, don't use the one example like time after time after time. So like if I come here in like a few more months and someone's talking about the Morris worm again, I'm gonna be like, oh my God, there's really nothing else that you could have used as an example. And I'm not sure if all managers are like that or all purse string holders are like that, but for me, that has a particular smell. And when I see it, I'm like, okay, could you not find a different example? Or why are you just using that one little particular thing? Is that all you knew, or is it really not that big a problem? Or it has a bit of a right. So just something to think about. But otherwise, yeah, go Fortran.
Yeah, and that I think Morris Worm, because we covered even on the show, to be fair, but only because we were marking history. And I think if I remember at the time, it was also quaint about not the Morris Worm, the SQL Slammer, I believe.
Yep. Mm-hmm.
And that was the quaint era when it was like it hit 200,000 systems. This is how big the internet was at the time. So it's also a little bit of like I like where you went with that, because it ties a little bit back to my complaint about the pie chart. There is a skill in communication and grabbing attention and saying like, here's a cute and fun reference to something literally from 20 years ago versus here is how ransomware used credentials or ransomware used a very known, easily patched exploit that just happened to be a memory safety issue. Or this is why we have yet, the 0 day. This is why Android is being patched on a weekly basis, or iOS or Chrome or et cetera. There's a lot of modern software that could be pointed to here.
And I just remember there's one more thing in this White House thing I want to bring attention to. Because everyone, or most of the things over the last week, have been talking about the memory safety, or maybe some have been talking about the hardware safety, which they cover in there too, which is an interesting aspect. But the third one that they mentioned, software measurability. We talked about this in the past. And I'm lucky enough that I get to work with some really smart folks in this area right now of how do you verify, right? How do you build the model to actually verify that the software is doing what it claims to be doing? I mean, you think getting budget for AppSec is bad. Getting budget for those type of people, that's really sort of insane. But it's something that for some of these things, we really need to think as a community. We really need to think more about doing it. I don't know. I mean, Emily was talking. We really are seeing how many callbacks we can make. She was talking about we need more security people to show up to CNCF tag security, or these different bodies that are out there. ASF has a security team too. Like, we can't have the developers doing it. But the next thing is like, okay, can I get those academics who have a bit of like either a mathematical or a statistic background to come in and start saying, hey, let's look at one of those 5 Rust TLS libraries, and like, can we actually mathematically prove that there's not going to be either a DOS attack or DOS vulnerability or a deserialization issue, or like all these type of things. And I'm not just talking about running them through like Fortify or pick your SCA. It's like, how can you actually build a model which stresses and tests it and actually proves in a mathematical manner that it does what it should be doing?
Yeah, and I think Heartbleed did launch, at least from my awareness, a lot of here's the formally verified version of a TLS stack, which makes sense for an investment in such a core piece of software, core foundation. Formal verification might have been helpful with that DNSSEC issue, because that would have shown the combinatorial explosion of these keys, these signatures, and boom, this is going to explode, even though and cause unintended side effects. So I like that, and I don't know that we're going to get anywhere, because fuzzing is the technique of the day, and generative AI being pointed at repos to find bugs is the other fun thing to do. So
there's a homework problem for our homework assignment for our listeners, is go and figure out how to do software measurability for artificial intelligence.
I think that's we have to end there, because that's the excellent homework assignment for all of our listeners who are now excited to go spend their week playing with that. So thank you, John. This was another fun trip through a week of AppSec news and adjacent. So thank you for joining us.
As blast as always.
Thank you, everyone, for listening. Please do subscribe, share on the socials, check out the show notes, and speaking of looking at code, check out Nightly Review from Hello Meteor. We'll see you next time on Application Security Weekly.